A car accelerates from rest. A car accelerates from rest at constant rate alpha for some time, after which it decelerates at a constant rate beta. Again it is coming to rest. If the total time lapse is t seconds, then find the maximum velocity reached by the car and also total distance covered by the car. This is our question. So for this I am taking here time and here velocity. Here I am taking time and velocity. This is the curve. So this is x-axis and this is my y-axis. Starting from rest, so initial velocity 0 and with constant acceleration. In the case of acceleration, I am taking like this. What is the acceleration? When force exerted, automatically velocity gradually increases. That is called acceleration. So it is reaching maximum position. After that what happens? In this case, what is the acceleration? Alpha. Again, it is coming to rest due to retardation. So from this maximum velocity, what is this? Maximum velocity. Again here what happened? Retardation created. So what is the retardation? Beta. So opposite to the motion of the car, like brakes, when applied, force applied in the reverse direction to the motion of the car, automatically its velocity gradually decreases. Finally it comes to rest. So that only happened. Finally its velocity became rest. In this total time duration is t time. Like this increasing and decreasing total time duration is t time. So last time is t seconds. Then what we are finding? Maximum velocity. Here two things he had given. One is finding maximum velocity. Again what happening? This total displacement covered by the car. This is our question. So in this case, first we are finding maximum velocity. Now I am assuming to reach maximum velocity it is taking t1 time, t1 seconds. Total time t. So from this t1 gone, remaining what? T minus t1 seconds. So in this t1 time it is reaching maximum velocity. So now you go to this case. This I am taking first case, this I am taking second case. Now you go to first case. In the first case, what is the initial velocity? Initial velocity is 0. In this case, what is the final velocity? V maximum. So what is the final velocity? V maximum. How much time taken from initial to V maximum? T1 time taken. Now what is the time? T1. This total T, this T, don't compare. Just generally information, time is represented with T. Again, now what we are finding? Acceleration. What is the acceleration here? A equals to alpha. So now I am applying first kinematic equation. What is the first kinematic equation? V equals to u plus at. That is first kinematic equation. So V equals to u plus at. This is first kinematic equation. In this you apply. What is the V? V maximum. Initial velocity is 0. What is the acceleration? Alpha. Into what is the time? T1. Now what I am getting? V maximum equals to alpha into T1. You take this is my first equation. Similarly, from here to here it is going to retardation. That case I am taking. Now I am taking case 2. So in the case 2 what happening? Retardation happening from maximum velocity to 0 velocity. So now you go to retardation condition. Now I am taking case 2. So in this case 2, what happens? Here what is the initial velocity? This is maximum velocity only, initial velocity. So initial velocity, maximum velocity. What is the final velocity? 0. What is the acceleration? Minus beta, because it is retardation. Now how much time taken here? Time equals to t minus t1 seconds. T cancel, minus t1 equal to 0. Like that you don't compare. Time is represented with t only. In this case t1, in this case t minus t1. Like that you compare. Again you go to first kinematic equation. What is that? V equals to u plus at. Now what is the V final velocity? 0. What is the initial velocity? V maximum. Plus what is the A value? Minus beta. Into what is the time? T minus t1. T minus t1. From this also again I am finding V maximum. In both cases V maximum same only. By comparing these two equations I am getting again final value. So what is that once you see here. Now here what happens now? This implies 0 equals to V maximum minus specific minus beta into T minus T1. So here what happens? V maximum that equals to beta into T minus T1. Here from this first equation what I am taking? What is the first equation? First equation V maximum that equals to alpha T1. Now I am changing this. I want to find the time T1. Then what happens T1? V maximum equals to alpha T1. This I am taking. Then what about T1? T1 equals to V maximum by alpha. This is my equation number 3. So this T1 value is substituting in that. Then what happens? Now this implies 0 equals to V maximum equals to, if you want you take this fourth equation, no problem. 4 implies V maximum that equals to beta into T minus T1. What is the T1 value? V maximum by alpha. By doing mathematics we are getting maximum velocity. That is the first case. Again what we are finding? Displacement. First we go to maximum velocity. This implies V maximum that equals to beta into T minus beta into V maximum by alpha. I want to make V maximum, so you take this side. So before that you take beta common. Beta like that only. Again no need to take divide because we want only maximum velocity. So that equation as it is, beta into T minus V maximum by alpha I am taking as it is. This beta coming this side. Then what happens? V maximum by beta. That equals to remaining what? T minus V maximum by alpha. You take V maximum left side. Then what happens? This implies V maximum by beta plus V maximum by alpha that equals to T. Again I am taking V maximum common. Then what I am getting? 1 by beta plus 1 by alpha equals to T. Now we take LCM. This implies V maximum into alpha beta is the LCM. Beta cancel, alpha plus here beta. That equals to T. Now I want V maximum. What about V maximum? T into reverse happens. Alpha beta by alpha plus beta. Finally I am getting V maximum. What is the V maximum? Now V maximum that equals to alpha beta into T by alpha plus beta. This is my equation number 5. One question completed. What do I want? Maximum velocity completed. Now again you go to total displacement traveled. What is the formula for displacement? This is the velocity and this is the time. Velocity time curve occupying area with x-axis gives the displacement. Why? I am taking velocity into time. What is the velocity? Rate of change of displacement. Again time is t. T cancel. Like that assuming finally getting dx. Dx means what? Displacement. So how waiting for displacement? For that here what created? One triangle created. Area of the triangle half into b into h. B is the base, h is the height. So second thing, first thing completed. What is the second thing? Second thing is belongs to area. Now what is the area? S equals to what? VT curve occupied area. VT curve occupied area with x-axis, that is called displacement. Now what is the formula for area of the triangle? Half into b into h. Half into, here what is the b? Time. Here what is the height? Maximum velocity. So that is the displacement. So S equals to half into t into, what is the v maximum? Alpha beta into t by alpha plus beta. Now this is what I am writing. This implies S equals to half into alpha beta by alpha plus beta into t square. So that is the displacement. Otherwise you multiply numerical total, numerator by total rate and write one fraction. So that is the displacement. So in this way we are finding maximum velocity and displacement in the given case.